and I want to tell you some introducing notes. First of all, who of you has been on our Global IoT Day event? Okay. How do you like it?
Happy.
How do you like it?
Gorgeous.
And you? Well, it was a really amazing event. We have had more than 500 attendees from all over the world. We have had 36 speakers from Austria, from Slovakia, from Czechia, from Germany, from Belgium, from France, from Spain, from Switzerland, and also from Canada. They all have traveled to Vienna for free and offered their awesome talks. It was really amazing, and we have been asked to do it again 2016. Who will be agree that we have to do it again? Yeah! Okay, I want to tell you something about the coming events. First of all, on May the 19th, we have an IoT workshop here at Stockholm again. Harald, what will be the topic of the workshop? Okay.
IoT topic.
IoT topic, yes. How we make our IoT devices think about the things we will do at the workshop. Then on May the 29th, we will manage a hackathon. We have little robots, and they have to find their way through the rooms. I think it will be amazing. This hackathon will be next to the Pioneers Festival. The Pioneers Festival will be on the 27th, 28th. There will be the IoT Challenge from Cisco, and direct after the Pioneers Festival will be our hackathon. Then, in June, there will be the Eclipse Demo Camp here in Vienna, which will be managed by us and Unifera again. If you have done something with one of the amazing Eclipse projects, don't hesitate to come to this event, offering a talk or being curious what has happened in the Eclipse Foundation development. Then in 10th and 11th of June will be the Überall App Congress, I think in Herzogsdorf. And there will be a really awesome talk about IoT, and if it will be heaven or hell. And this talk will be held by a really awesome speaker by myself. The same talk will be offered from me at the Imagine 2015 in June the 11th. The Imagine 15 is a congress organized by the Federal Ministry of Traffic, Innovation and Technology. And what did I have missed? Something I didn't like to hear. There will be an IDC conference about IoT. It's here on the 23rd of June. It's also me. I have no time to come to the meetups because I'm traveling from congress to congress or being a minister. So there are the coming events, IoT events here in Austria, and I want to finish with a site of one of our guests, international guests at our IoT conference. Vienna has become one of the most important hotspots for IoT in Europe. Thank you. You have managed it. So our first talk will be by Daniel Ammersberger. Me. And Daniel will present you how you can use your IoT device for open source PLC. PLC stands for Programming Language Controller, used in industry for controlling machine process. Welcome to Daniel.
Thank you for having me again. For those who have been to the Global IoT Days and heard my talk, there will be some repetitions because we are talking about the same hardware, but this time with the main focus to PLCs. So, checking my controller here. Yeah. Okay. So, I want to talk to you about open source PLCs, a topic that is, I think, pretty new because PLCs are usually quite closed source. First question, does anyone not know what a PLC is? Should I explain? Okay, a lot of people. Okay, PLCs, that's a programmable logic controller. And let's skip the introduction. The programmable logic controller is a device that usually is used to control machines, usually industrial machines. But in times of home automation and building automation, it is also used to control buildings, lights, or other actuators, switches, whatever. And the nice thing about PLCs is that they are pretty simple in the construction. They read inputs and write outputs, and in between they execute a short program. But they are very efficient at real time, controlling. So if you need to control a machine, or if you want to control things in a specific amount of time, PLCs are the way to go. So nowadays, PLCs are also very interesting for building automation and, of course, for home automation. But industrial PLCs are pretty expensive, so usually when you're going to home automation or automating other things, you wouldn't really use those kind of controllers. But the nice thing is they're really powerful and they are quite modular. Things that are pretty hard to do with current microcontroller or microprocessor platforms like the Raspberry Pi and every one of those. Because you have shields, you have add-ons to those boards, but they are usually not very flexible. So a PLC is pretty much a controller that just reads inputs and writes outputs. So I will show you what that means. We have created an add-on board for the Raspberry Pi, which anyone doesn't know what the Raspberry Pi is? Okay, so yeah, so that's a given. It's a mini Linux computer, and we created an extension board that lets you control things, read things and write things, and in a lot of different ways. I'll show you later. So that is the extension board, and this extension board has its own extension boards plugged onto them, which lets you communicate to the real world, read inputs, write outputs, or control lights, motors, whatever. I'll show you, first off, I'll show you an example showing a really simple machine we've built in the office to populate our boards. And this machine is controlled by exactly this board. So this board creates the board it is running on. So that is one application you can realize. What it is doing is it controls these feeders with components, and it moves all the axes and places the components on the board. So all that is done by this controller and 4 extension boards plugged into this. And that is how you can program it. So there is a unified language for PLCs, which is standardized all over the world. And so you have the same language for all kinds of PLCs. So this is a standard. And what we have here is an open source tool, which is not created by us, but it helps us getting to our goal. And this program converts these ladder diagrams. This is, you can call it source code, converts these ladder diagrams into structured text, which is also a standardized language for programming this kind of controllers. The pretty thing is you don't have to know anything about programming. You can more or less drag and drop items into this window, connect them, and you have a working program. So if you just follow the lines, these are incoming switches and these are outgoing switches. And in between you can write your program and design your program. And in this case, this is a very simple program which sends the text "Hello World" every 5 seconds. And that is all you need to program or do to make this kind of system. Of course, you can think of home automation, so you can also put in a light switch here and a light bulb here, and it will switch on the light bulb for a certain amount of time, or depending on the daytime, or if it's dark or not dark, depending on the light sensor or whatever. So this is a very simple way to program these kind of systems, and we have adapted the software to enable programming our controller. This software doesn't create anything but this code, which is, I mentioned it before, a very simple programming language, ST code, structured text. And we have added a configuration dialog which enables you to program directly, to compile and program this directly onto our extension board via the Raspberry Pi. So yeah, that's pretty simple and straightforward. What you can also do is create this source code with our online firmware compiler. So we have a website where you can go and where you can select the modules you have in our main board. In this case, we have 8 digital inputs, an RS-232, probably a serial port you might know, a one-wire port, which is pretty nice for wiring up sensors, and in this case, we have a GPS module, which gives you the GPS location. You just plug in the modules, you can create the firmware and download it. But you have also this little button to enable the PLC mode, and that gives you a code programming window directly in the browser where you can put your code, compile it, and generate the firmware. And the firmware is then programmed by the Raspberry Pi to our extension board. This is the next nice thing about this engine, is that you can run your web server on the Raspberry Pi. So the thing is, all your programs that you code are running on our extension module on a dedicated processor. So no matter what you do to the Linux computer, to the Raspberry Pi, the program will keep on running in the background. You can reboot the Raspberry Pi, you can unplug the Raspberry Pi, and the program keeps on running. So if you have an unstable Linux installation, it doesn't matter. But you can talk to this extension board through the Raspberry Pi. So in this case, we have a running web server on the Raspberry Pi talking to the extension board. And you can imagine that you can create pretty easy visualizations for your sensor values or your inputs or your outputs. So it would just require a couple of lines of HTML5 code to give you a button that lets you enable your coffee machine or whatever lights on the ceiling. And of course, it would also run on your mobile phone. You can create an app that just sends a web request and turns on the light or whatever. Turns on your coffee machine, like I have it in my home. My coffee machine is controlled by one of those things. So I have a little app to activate my coffee machine, or things like that. So that's pretty much the easy way of programming this kind of system. You also have the possibility to talk directly to the extension boards if you want to through the Linux system, through the Raspberry Pi, but that I explained in my earlier talk. The really interesting thing about this is that you can connect real-world objects to the Raspberry Pi and still being independent of the Raspberry Pi in the execution. So you can create very stable systems and you can program real-time systems, which is very important for machine controlling, and that's the benefit of combining a separate controller and not running the code on the Raspberry Pi itself, since a Linux system always can run full of the memory can get corrupted, or the SD card is full and your Linux is stopping to work, and all that issues you don't have when you're running your code on a separate processor. So you can reboot the system as often as you want. So, what are the next steps for this system? We think this is a very interesting controller, not only for automation, but also for like home automation projects or small projects you put yourself together. And what we want to do is enhance the possibilities to program this environment, not only with this pyramids editor you saw before, but with a real GUI editor in JavaScript. So you just have your Raspberry Pi, a website on Raspberry Pi, which is giving you all the functions you need, like a simple GUI editor to program your logic into this controller without having to know complex languages like C or C++ or anything like embedded languages. And we also want to add Scratch support, which is a very easy to use learning programming language, which is, as you can see, a very graphical plug and play language used in education. So this is really pretty much about combining the efficiency and the stability of industrial applications and easy to use software endpoints to adapt it not only to industrial applications but also to hobbyists and learning applications and home automation, which is, by the way, building automation is one of the most requested features for this product, and we have requests from all over the world, from Israel, from France, from the United States, and they all want to use it mainly in building automation, because this combination of having all these possibilities to talk to the real world, and on the other side, this easy programming and these rich features to show GUI elements to you in HTML5. That's really the nice thing about it. And you saw the pick-and-place machine before. Implementing the code on this module took like 15 minutes. That's all it took to control the feeders that showed you it was a little bit small, but all the parts are coming from the feeders behind. I'll show you once again. There are small little parts which are feeded forward and picked by this nozzle, and this is all controlled by this board, also the motions, and it took 15 minutes to program this motion and the picking of the components. Of course, the background software that calculates all the coordinates and where to go, that was more complex, because there's a vision system inside that checks the part and the orientation, but just the movement and the feeding, that was a 15-minute job with this GUI editor. So yeah, that's the software part. For the hardware part, we of course want to add more modules to support more applications like KNX used in home automation, or wireless protocols and technologies. We also are working on a case generator, which is open source, and you can see the first steps here. So this is a parameterizable case with an open source CAD software, and we are also working on a more professional, more for the industrial usage, a DIN-mounted version of this board to enable real industrial applications too. And of course it's all open source, the software is all open source, so you can change it as you like. And we hope that a lot of people will help us developing this software further and build nice things with this platform we're giving away for free. Thank you.
Thank you, Diego, for an amazing talk. Is your product just available? Can I buy it?
Well, we are doing low quantities now.
Okay.
So there is no shop carrying right now. So currently we get a lot of emails. Can I have one board? And we package it and send it to the next one goes to Israel right now.
Okay.
The next to France, but it's not in volume yet.
Okay, thank you. Any questions?
You mentioned that there is a standard programming language for PLCs.
Yeah.
Which one is this?
It's the IEC 613. I can get it for you. IEC 61305 or 311. And they, this standard defines this ST code you saw before, this structured text, the ladder diagram, and another language called IL, instruction list, which is used pretty often with PLC programs. AVL Anwendungsliste, and that's IL, that's instruction list, yeah.
I have a question. When you were talking about putting the visual programming language of MIT on there, the Scratch.
Yeah, Scratch, yeah.
How far along are you with that project? Or you're gonna put together the instruction lists with that Scratch?
No, Scratch is more like a Java-based language. So we have this, what I showed you very briefly before.
One other question. Are you going to use the GUI of the Scratch, or are you going to use the actual engine of the Scratch as well?
No, we will use the actual engine of Scratch, and we translate the calls, which are JavaScript calls, into these web calls we support. So we already have this web API where you can trigger everything through JavaScript calls. So all we need to do is match the back end of Scratch with these calls.
Right, the instructions that has to be matched.
Yeah, exactly.
Okay.
So it's not a huge deal.
And your API is based on web service definition language, or?
This is a very bare bone version. It's not. It's get and post.
Get and post. XML or data?
It's JSON.
JSON. Okay.
Yeah.
Further questions?
I would like to review maybe that I understand what you can do with each part and what you can do with both of them.
Okay.
So.
Okay, so I'll go back to this picture, which is a pretty nice overview. So you have the Raspberry Pi here, which is in white, which you know, and you have the main board below, which has the microprocessor and some other logic, and you have, in this case, you have 4 equipped modules which are mounted on this board. I can show you hardware later, so you can see it physically. And in this case, you have, for example, you have 8 outputs, RS232, 1 wire and GPS. What that means is this 8 output module just has 8 digital outputs, which you can set per software if they're high or low. And you can trigger relays, for example, to switch on machine motors or lights or whatever, or various other stuff. And the opposite would be the inputs, which are just digital inputs. So if there is a voltage on there, you can see it in the software, on the software side, and act accordingly. And the RS232 is a very common serial protocol.
I'm speaking from the use case.
Okay.
So the PLC is very fast, real time,
Yeah.
and in order to program it, you need to connect to it directly with a special machine normally.
For example. Yeah.
Then you put the Raspberry on top to be able to get flexibility, to win flexibility in terms of management of the.
Exactly. Yeah. Programming and visualization and all that kind of stuff.
And this
and
is
connecting it to the internet, of course.
and this is the main advantage that you get. So you have a PLC which is much more controllable from distance and so on.
Exactly. You have a PLC which is perfectly connected to the internet, which is very easily to visualize in terms of a web service and HTML5 website, which is interactive. And of course, the third part is it's much more flexible than any other PLC because you have much more extension modules. You have things like a GPS module. No PLC in industrial environment is a GPS module. We also have a module for sending and receiving short messages, so and communicating over a wireless network. So you can put in a SIM card and receive and send SMS texts to the machine, so it closes your or opens the door or whatever you might want to do with it. So we have a lot more flexibility in terms of modules, and you have the added feature of Linux computer behind it, controlling all that things. So, and of course it's a lot cheaper than buying a PLC, because PLCs can easily cost up to 1,000, 2,000, 3,000 euros, easily, one.
Okay.
And this board will be like 50 euros.
Okay.
Last question. I have a question. Oh, was you ever thinking about the message queue on the Raspberry Pi side, which will be intercepting the messages?
The message queue.
Yes.
I need a bit more explanation for this question.
Okay, if you are integrating the data later on, for example, for reporting purposes, you would like to keep the order of the messages. If you have, let's say, you have to achieve that the data points and the messages will be in correct order. And for that purpose is message queue program used. For example, RabbitMQ, which is open source or something like that. Are you considering something like that?
Well, we have I can explain it later to you in detail, but we have a much more flexible approach because we have a Linux kernel driver on the Raspberry Pi side. And this includes specific files for reading and writing variables, for example, and it also includes loading additional drivers which can directly communicate to the modules. For example, if you plug in an RS-232 module, you automatically get an RS-232 port on your, so a TTL, a T2Y port on your.
Okay, and what if I will receive the message from RS-232 and at the same time the message or the signal on my digital output? How you can achieve the correct order of the inputs?
Well, the order is pretty straightforward in this case because there are two modes. I can explain it later a little bit more, but there are two modes. There is a PLC mode, which acts like a PLC, and there's a way of getting the order wrong because it's a cyclic program, and there is a phase where all data is read, then execution of the program, and then a phase where all data is written. And this is and data always comes out in the same order. There is no way of mixing them. It's single-threaded. Don't forget, it's a single-threaded thing on the
Yes,
side.
I know how to see it, but from an integration perspective, there are. Okay, let's see.
And we can talk about it later if you can.
Yes, maybe I don't understand it. And
yeah.
was you ever thinking about the higher level integration protocol
Lucas?
for PLCs like OPC unified architecture or something like that?
Lucas, can you
Not
put
yet,
your question to the breaks because we are running out of
Yeah,
time.
we're talking. I'll explain it to you.
Okay, thank you to Daniel. We make 10 minutes break.